I wanted to know how things worked. That was my first motivation. And then I saw that this research has immediate effect on how patients in the future will be treated or diagnosed. And I thought that was a more visible way of where research is going. So we are making nanobodies here, and what we do in the lab after we have the nanobodies is to test them on human cells. Nanobodies will be a future new biologic for the treatment of cancer and immune-related diseases. Just as the antibodies or any biologic is, so a biologic is a medication or a therapy that's produced in a living thing, which is something that's really a game changer for cancer immunology and for cancer treatment and for treatment of other diseases. And the nanobodies are part of this revolution in medicine. So I brought these Lego blocks to visualize nanobodies today. And they're from my children. They're very interested in science because I talk about it all the time at home. And they're interested in how the immune system works. One nanobody against a certain target that can inhibit something or activate an immune cell. But the good thing of nanobodies is that we can link them together. So in this case, we would call this a bivalent nanobody. It has two nanobodies to the same target, connected by a linker. It's also possible to make multispecifics. So if we take a nanobody against another target and attach them together like this, then we can inhibit target A and we can maybe activate target 2. We can also make it 3 or more, as many as we like, until it is getting harder to produce. Yes, we can also imagine that nanobodies cannot just be used to make the strings like we do now as multi-specific nanobodies. They can also be used to put them on part of a conventional antibody, because it's not to say that conventional antibodies are not good or they don't work. For some specific indications you need a conventional antibody. So what we can also do is take part of the conventional antibody and put nanobodies on top of this. So this is something that makes them very versatile. Since we became part of Sanofi, we have collaborated with many different sites because Sanofi is spread around the world. The Immuno-oncology cluster and the inflammation clusters are in France and in the US and in Frankfurt. We have really become more a global nanobody company now that we are part of this family.